Here we have a series circuit with a battery here, an LDR, a thermistor and a resistor. And there's a current of 5 milliamps. So turn our pin on. So I'm going to draw an arrow there. That's the current, but I'm going to put that into amps, so it's ready to go. 0.05 amps. We've got a voltage of 2.5 across the resistor, 2.5 volts here, 1 volt across the thermistor, and 10 volts across the LDR. So that's 11, 13.5 from the battery. Alright, the first question is saying calculate the resistance of the resistor. What have we got? We've got the current and we know the voltage across the resistor, so we can say the resistance of the resistor is equal to, we've got V equals IR, so if I rearrange that I get R equals V over I. V over I of the resistor, which is 2.5 volts, divided by 0.005 amps, and that gives 500 ohms. 500. Nope. It does something funny when I open it, that's why I always sweep up and down, and it fixes the problem. It seems to anyway. Right, same question up here. I've just got the information, so I can go onto number B. There's also a graph looking at the thermistor. The thermistor had 1 volt across it. Calculate the temperature of the thermistor. Okay, I've got a temperature graph which has resistance as well. So for me to get the temperature, the first thing I need to do is I need to calculate the resistance of this guy. So resistance is the same as I did before. Resistance of the thermistor, T, over I, is 1 volt over 1 volt. And the current is the same current all the way through, which I've had as 0.005 amps. 0.005, and that equals 200 ohms. So we've got the 200 ohms, we've got the resistance, and now I said we can read it off the graph. So from the graph, here's 200 ohms, 20 degrees. Right, next one. Again, I've just copied and pasted all of this, so you've still got the same thing. And that's now saying the characteristics of the LDR are shown. So the LDR was 10 volts. And we have to work out the light intensity. So graph of light intensity versus resistance. If we can get the resistance, we can get the light intensity. It's the same working as before. Resistance of the LDR is the voltage of the LDR over the current of the LDR, which this is a 10 volts from memory. Let's just check. Yeah, 10 volts, which I've got there, and again 0.005 amps. 10 over 0.005 amps gives me 2000 ohms. Alright, 2000 ohms on this. That's what I've got to read now from the graph. Now 2000 ohms, I've only got 0, 1, 2, 3, 4. But I've got kilo ohms. So 2000 ohms is 2 kilo ohms. So here we are, 2 kilo ohms. And it looks like it is 15 lux. Now, just before we go on to the next question, this is our voltage divider question. Normally we just have one battery, and we might have a thermistor and a resistor, and then we might have the voltage out here. We might have some sort of switching circuit. But in this case we've got 3. And it's exactly the same though. The ratios are still, it's all about the ratios of the resistances over them, and then the ratios of the voltages over them. So that'll help us out when we go to do the last one, part D. Again, it's so weird when it opens. Alright, so I've got the graphs, the same graphs we had before for the temperature. This must be the thermistor, and light intensity must be the LDR. A buzzer with a very high resistance is connected across the ends of the resistor. Now this looked like, if I was to just quickly draw it, we had the LDR, we had the thermistor, and we had the resistor, and here's going to be my buzzer. Buzz. Across that point and that point. Okay, it buzzes at any voltage greater than 2.4 volts. 2.4 volts is measured across here. It'll buzz. Initially it's buzzing. The student finds this very irritating and she wants it to stop buzzing. And she wants to either change the temperature of the room or change the light intensity to the LDR. She discovers 2 such changes that have the effect of turning off the buzzer. Describe any 2 changes clearly. Explain why each of them will turn off the buzzer. You may use calculations, but they're not required. Okay. So the buzzer will turn off when the voltage is lower than 2.4 volts on resistor. Okay, so we're going to do 2 ways to lower the voltage across the resistor. So the first way I'm going to do to lower the voltage across the resistor is have more voltage across the LDR. So I want to increase voltage on LDR, and it'll get more voltage if it's got more resistance. So the ones in series here, the ones who have the most resistance have the most voltage. So by increasing its resistance, and we can't just turn the resistance up, but we can change something on the LDR which will change its resistance. We've got here the LDR here. Its resistance will go up when the light intensity goes down, so when it gets darker. So this is achieved by making it darker. Okay, and then similarly we can increase the resistance of the other guy, and the other guy is the thermistor. Increase the resistance of the thermistor, the W. And how do we increase the resistance of the thermistor so it gets more of the voltage? Here it is here. Resistance goes up when the temperature is increased. This can be achieved by increasing the temperature. I'm just going to sum it up. You wouldn't need to put this, but I'm just going to sum it up so you understand. By increasing the resistances of the LDR and thermistor, we increase their share of voltage and therefore decrease voltage of the resistor. This is just me summing it up for you guys, but you only need what we've got here. But yeah, I've summed up by saying, by increasing the resistances of the LDR and the thermistor, we increase their share of voltage, and therefore that decreases the voltage of the resistor.